everyone, and welcome to Creativity, Collaboration and Community, where we're going to delve into what life is like as a creator in both Meta Horizon Worlds and in Crater. Both of these platforms provide powerful creative tools that can be used by experienced creators and novices alike. And both of them allow users to explore, play, and create social experiences and games to be enjoyed by others as they bring some of their wildest dreams to life. Meta Horizon Worlds does that in VR on Meta Quest, while Crater serves a desktop and a mobile screen-based audience via Facebook Gaming, Google Stadia, and Epic Games Store. But they've both been built from the ground up with these shared values of creativity, collaboration, and community. So I'm delighted to be joined today by a leading creator from each platform for a conversation about what those values have meant to them as they found their creative feet in these two amazing communities. First up, I'd like to welcome Daniel Martin Garcia, known as Tumbak7 in the Crater community. He's a Spanish-based creator who's built some of Crater's most successful and award-winning games, from mystical adventures to fiendish obstacle courses. And he's been a key member of the Crater community since the earliest days of the platform back in 2020. And we're also joined by Aaron Sorrells, who's a leading light in the Meta Horizon Worlds creator community, where he goes by the name of Unemployed Alcoholic. He's risen to prominence since the platform launched as the creator of the highly popular Soapstone Comedy Club, where he's poured his passion and creativity into building a space that allows people to shine and entertain others, all while telling the inspirational story of his addiction recovery journey. A very warm welcome to you both. And before we get started, I should introduce myself briefly too. My name's Natalie Griffith, and I'm the head of brand and marketing at Unit 2 Games, the meta studio behind Crater. I've been in the games industry for over 30 years, and at Meta since last summer when our studio was acquired. I'm super passionate about encouraging and empowering people to be creative in digital spaces, so I'm thrilled to be hosting this conversation today. Our goal over the next 20 minutes or so is to give you a sense of what it's like to be a part of one of these communities, and to offer a little insight and maybe inspiration to those of you who might be thinking about giving it a go. So, let's get started. So Aaron, turning to you first, how did you originally get involved in Meta Horizon Worlds, and had you done any digital creation like this beforehand? And also I understand there's a significant anniversary you've just celebrated.
Yeah, so Natalie, first off, it's great to see you. I'm so happy to be here sharing this stage with you and sharing a little bit about Meta Horizon Worlds and the experience I've had in it. As far as like what brought me into Worlds, it actually was a position of hardship that brought me to both Meta Horizon Worlds and also really into comedy as well. So I'm a recovering alcoholic, and I'm known as the unemployed alcoholic, and that came from a spot of addressing alcoholism in my life and battling through a period of unemployment. And from there, I found comedy. And then, of course, when the pandemic came along and really kind of flattened that whole industry, that drew me to the Metaverse. And now here I am today. And as far as anniversaries go, there's actually two very, very cool anniversaries. First off, about a year ago, at last year's Meta Connect, I heard Mark Zuckerberg's keynote address, and he talked about what was coming up for the Metaverse, and it really struck me as this was a very cool thing, and it was something I needed to get involved with. And then probably even more importantly than that is I just celebrated my 6-year sobriety birthday, so I'm now 6 years sober from alcohol, and things are going in a very good direction.
That's great. Congratulations on that, Aaron. That's amazing. And Daniel, what was your journey into creation before you joined Crater?
I discovered Crater by chance, thanks to my friend Vicente. We were in the lockdown at home due to COVID, and we said, let's play something. Crater appeared in the catalog. From the first minute, we fall in love with the platform and the collaborative mode. and how you can make games with other people and at the same time. That is super cool for us. And I did some game related stuff in the past, but it was only as a hobby. There was a game with an open tool set, and I created there some maps, quests, stories, but it was a long time ago, and it was only as amateur, not as professional.
Cool. So, as we mentioned at the top, both of these games have been designed from the ground up with user-generated content, UGC, front and center. So, Meta Horizon Worlds leans more into experiences and social spaces, whereas Creator is focused a little more on games. So, what I'd love to hear you guys talk about now is give me a sense of what inspires you to build the things that you've built. Aaron, as we've touched on just now, yours is a very personal story that's led you into this. So tell me a little bit about the comedy club when you first created it and what the inspiration was.
Yeah, so when I do comedy to connect with people. And of course, this platform has just been an extension of that. So that was really the motivation behind getting into Meta Horizon Worlds, was to be able to connect with people and do comedy.
Cool. And Daniel, you've been quite the prolific game creator in Creator. We can't stop you building stuff. You've done everything from massive adventure games through to obstacle courses and architectural constructions. What inspires you at the start of each project? What is the nugget that gets you going right at the beginning of each new game?
I've been playing games for a long time, and I'm not quite sure where the inspiration comes from. But I think I just make games I would like to play and environments I would like to see. And I think when you create something that you really like, the result is always better and you enjoy the process much more. That's the what inspires me, is to create things in that way.
So obviously creating in VR, Aaron, is very different from creating on flat screens. You've got to get your head around how to operate in that VR space before you start building anything. But then the scripting system in Meta Horizon Worlds is really intuitive with sort of drag and drop code blocks. Give me a sense of how you learnt to kind of build effectively in Meta Horizon Worlds and kind of what your sort of learning journey was like.
Yeah, so there's one word that comes to mind, and that is collaboration. The way that I've been able to achieve stuff and learn stuff is through collaboration. There's just an incredible group of people. There's an incredible community in Meta Horizon Worlds where there's people just willing to help out as far as building itself, and also as far as teaching you and going that route.
And Daniel, obviously for Creator, because it's screen-based, I think a lot of people are already familiar with a keyboard and mouse setup. So that part is perhaps a little less intimidating. But in Creator as well, it's useful to have some Lua scripting knowledge to be able to build things. So what was your learning journey like? What did you do to kind of learn the basics and start creating things in Creator?
I have to confess, I'm not very good at Lua or coding, but I've learned a bit in a very natural way. In Creator, you don't need to know anything to make games, only passion. In the community, we help each other, and there are many packages with templates, which are like plugins, really similar. And it's content made by community members that you can put into your games, and it's ready to use. You don't have to create all the game. There are many tools to design the environment or the behavior, and that is really awesome for creators.
Great. And obviously you've both spoken a lot already about collaboration. And as we said at the top, that's one of the key things that we wanted to be talking about today. So Daniel, for you, the Creator creators work very closely together in our Discord server while they're building things. So can you give me a sense of how that works and what you find most useful about that kind of interaction?
Sure. Collaboration is everything for me. You are not alone at home doing something. It's like if you were in a big virtual co-working office with cool people, and it's really fun. Also, if you don't know how to do something, you can collaborate and associate with people who know how to do that part of the game. You can create things at the same time with your friends. You can see what they are making in real time. I really like that aspect of the game.
And Aaron, for you, obviously, a lot of the collaboration happens via the built-in voice chat in MetaQuest for Meta Horizon Worlds. What's your experience been of kind of finding other people to work with and then actually collaborating with them in the game?
Yeah, the bottom line there is building is a lot of fun. When you're in Meta Horizon Worlds and you get into the world, there can be 4 people in there at a time that are building, and oftentimes we're working on individual things, and then somebody will invite a person over and collaborate a bit, work together on it, solve a problem, and it's just a good time. It's a community experience. It's very cool.
Fantastic. And talking about those communities, you're both super active in your respective communities. So staying with you, Aaron, the success of a comedy club, whether that's in the real world or that's a virtual one, that depends on having an engaged audience, right? So can you tell us what you've done to try and promote the club and actually get people involved and get them to come and watch the shows?
Yeah, so it's interesting because really what our secret sauce is, what has made us successful, I think, really doesn't have much to do with promoting of the comedy club. What it is, and I mean, don't get me wrong, we put great shows on, we do wonderful experiences like that, but ultimately we've got a simple 3-point to-do list of what we're really trying to accomplish in the club. And that's one, to empower leaders. So anytime there's a person who's positioned to where they might be able to step into a role and do some stuff, that's why we're there, to put them into leadership positions and help there. Secondly is to encourage people towards the spotlight. And because that's our purpose, the whole everyday open mic experience, like it just works. It just flows. And then the third thing, which I think is very important, especially given how new this all is and how many people are curious about it, I'm here to share what I'm learning. And that's been quite a bit. I've stubbed toes along the ways and learned some lessons, and I'm just here to share some of those.
Fantastic. And Daniel, you've played quite an interesting part in the creator community. You're one of the driving forces behind our Spanish-speaking sort of sub-community. Can you tell us a little bit about how that came about?
Yes, sure. It started because we had some friends who wanted to learn how to make things in Krita, but some of them didn't know English or have difficulty with it. There were also more and more Spanish-speaking people in the community. So we proposed to the Krita bosses to create a section of the Discord focused on them with video tutorials or streaming lessons. They say yes, and now every Wednesday we give classes via Discord, and sometimes we create a game together and help new members. And yes, that's part of the community.
Brilliant. And you've both done an amazing job to actually pay it forward, the passion that you're experiencing in the community, and make that inclusive for more people. So that's fantastic to see. We're going to need to wrap up soon. So to both of you, I have one kind of final question. What's the most important thing you've taken away from being a creator in these communities? And what one piece of advice would you give to a newcomer? I'll throw it to Aaron first.
So, I mean, the most important thing for sure is that just people are awesome. As we've had the opportunity to engage with people, to put people in positions, where they can accomplish things, like people are just made to shine. People are made to excel, and it's been awesome to see that happen. So that's cool. As far as like advice to a newcomer, the big power of Meta Horizon Worlds is that it makes things accessible to people. So if somebody's trying to get into this and find their spot, find their niche, the thing to do is to figure out what they have, what experience they have, what place do they know intimately, and figure out then how to use the platform to make that accessible to people. And if they do that, the sky's the limit. Or actually, the sky's not even the limit. We can go way past that.
And Daniel, what about you?
What I'm most proud of is some of my games. They are like my children's or something like that. In particular, Ruins of Mahura, it was my first game. I made it with my friend Vicente, who I told you about before. I really enjoy a lot doing it, and I'm super happy when I see somebody streaming it or playing it and enjoy my content. Is really what I take of this community is super cool. That and an advice for newcomers. I know sometimes it's hard and difficult, but I encourage you to try always to create things with passion and having fun with it. If you have fun creating it, people probably will have fun playing it. And if not, at least you had fun in the process, and that's already a success.
Absolutely. Fun, passion, and collaboration. I think they're probably the good points to end on. Before we do, though, Daniel, I wondered if you'd perhaps like to share something in Spanish to our Spanish-speaking viewers today.
Sure. Hola, ¿hablas español o estás aprendiendo a hablar español? En Creta hay una comunidad de hispanoparlantes en la que nos ayudamos entre todos. Damos clases sobre cómo hacer cosillas, hacemos tutoriales o nos ayudamos entre todos en algún proyecto o en algún juego. Somos muy majos y así que si te interesa el mundo de la creación de los videojuegos, es una oportunidad laboral muy interesante y es muy divertido. Solo tienes que unirte a nuestro Discord de Kraita y ponerte el rol de Spanish y te aparecerán los canales. Así que únete, que te estamos esperando, que te va a encantar.
Huge thank you to both Aaron and Daniel for joining us today for what I hope you all found a really inspiring chat. Here at Meta, we continue to be blown away by the passion, the dedication, and the creativity of all the creators in our products. And as we build towards a broader vision of the Metaverse, we look forward to welcoming many more of you into the world of creativity, collaboration, and community that Aaron and Daniel are already getting so much out of. If you're interested in taking a look at Meta Horizon Worlds, then simply search for it on your MetaQuest store. Or for Crater, then head to fb.gg/Crater. Thank you for joining us.
Wouldn't it be great if anything we built for the Metaverse worked across all of it? Hi, I'm Andy Shenton, Head of Studio at Unit 2 Games, a Meta studio. And as one of the founding members there, I've been working on Crater, our cloud-streamed and PC-based creation and publishing platform for almost 5 years. Since joining Meta, we've been working increasingly closely with Meta's Horizon Worlds teams, including engineers like Alex, to bridge and develop Metaverse technologies.
I'm Alex Hopman. I've been an engineer here at Meta for the past 6 years, working on Facebook games, and for the last year on the Metaverse, collaborating with the Crata team.
Meta doesn't just have one Metaverse product internally. There's a whole bunch of different applications across a range of devices and screens exploring this space and connecting with each other. Today, we represent 2 of the creative products by Meta, built from user-generated content, Meta Horizon Worlds and Crater. These products and teams have different target audiences and devices, but are coming together to build a collection of shared standards and technologies, providing steps towards interoperation. These platforms provide powerfully creative tools that can be used by both experienced creators and novices alike, allowing you to build games and social experiences for others to enjoy as you bring some of your wildest dreams to life. Meta Horizon Worlds does that in VR on MetaQuest, while Crater serves a screens audience across desktop and mobile on Facebook Gaming, Google Stadia, and Epic Games Store. Through steps towards interoperation, we are aiming to create bridges between these communities and meet creators and players both where they are and where they will be, across screens and VR. Now, Alex will tell you a little bit about how we're taking inspiration from the early development of the internet.
Meta is committed to our collaboration with the Metaverse Standards Forum and the other participants in the Metaverse ecosystem. At the same time, it's really early days in the development of the Metaverse, and it's worth thinking about how the early web developed. I had the privilege to participate in some of the early web standards development in the IETF and W3C. One key observation from that time is that most of the key standards were not initially developed by standards committees thinking through some hypothetical futures, but instead came about through evolution and iteration towards real use cases. SMTP, HTTP, HTML, JavaScript, AJAX, and many other key innovations that power the internet today were initially developed by individuals or teams who just wanted to solve a problem and build a cool piece of software. That early phase, where you're figuring out how to make something compelling, requires fast iteration and exploration. Compared to the early web, the metaverse is already incredibly complicated. Rendering, shapes, environments, animations, scripting, physics interactions, real-time low latency networking, pathing, and more. Basically, it's all the complexity of a modern game engine, plus a bunch of extra services unique to the metaverse. It's hard enough to upgrade a game from one version of a typical game engine to another. Building all these deep services in a way that is interoperable is going to take a long time to figure out. In the meantime, there are a couple of key building blocks that we hope will enable you to connect experiences together in the future, and these are the ones that we at Meta are focused on between the Meta Horizon worlds and Creta right now. They start with identity, avatars, and travel. In the future with identity, you'll be able to travel between worlds and still be you with your friends and group exploring together. With avatars, you will be able to have your appearance and take it, when appropriate, between worlds. And with travel, worlds will be able to link to each other much like hyperlinks in the web, even if built on completely different underlying technologies. My take is that one day the mass market will be AR glasses. Both VR and AR devices will be ubiquitous and convenient, and probably blend together. But right now, we expect that most of the metaverse visitors will be engaging with normal flat screen devices, both PCs and mobile. These can both be more convenient to hop into a space with your friends anytime, as well as more powerful for now for creators looking to build sophisticated experiences, including elements such as scripted behaviors and interactions. We believe people want to explore the metaverse without having to exclude their friends who don't happen to have a specific device.
Today, the majority of people consume their content through screens, but with a dedicated and growing segment using VR. As Alex mentioned, there have been similar device transitions with a dominant consumption shifting from desktop to mobile. But support for both remains first class and suitably adapted to the device. We'll be working to prioritize first-class offerings on desktop and mobile screens, but with fidelity optimized for those devices, as well as providing immersive presence, which you can only get from VR. Let's look at how all of this informs what we are building, with a pair of case studies about how we've begun to work towards bridging this gap between Creta and Meta Horizon worlds. First up, avatars and identity. Creta has a vibrant community using our avatars, outfits, and cosmetics, but they are all contained inside and only exist in Creta. We want to give our community the opportunity to bring their identity with them into Creta and express themselves not just there, but across a range of our apps, and where supported, other developer products. Creta's users will soon be able to link a Meta account to their Creta account in order to bring their Meta avatar into Creta. We've done this using a couple of different technologies, all bundled into the Meta Avatar SDK. We expect this will allow Creta and Meta Horizon Worlds communities to choose a single, well-defined avatar to present themselves in both applications, and further, bring with them any outfits from other parts of our platform. As you can see, the fundamental avatar and identity remain the same, but presence and fidelity scales to what's best for each platform. On Creator, we've used the Meta Avatar SDK to build support for Meta Avatars, in the future working alongside our existing Creator avatars, and to begin to interoperate with the Meta Avatars of Meta Horizon Worlds. As a developer, you'll be able to get involved here too. Unreal Engine support for the Meta Avatars SDK will be rolled out to the broader developer community soon, and that's on top of the established Unity support. While we are building this with Creator, we've been really impressed with how easily we managed to adapt the avatars to our existing codebase, and then how quickly they started to look at home in our environments. Okay, so that's avatars. APIs, technologies, and styles in this space are moving fast, so it's well worth checking out and keeping tabs on them, even if you've maybe looked before. Next, creation, and this one's tough. Both Creator and Meta Horizon Worlds specialize in allowing our users to build stunning experiences and games. It's something we're really proud of. But at the moment, these creations are only available within the product they've been built in. And as we ultimately want to make it easier to exchange creations between Meta Horizon Worlds and Creator in the future. While there is a huge amount of work to do to bridge these creative spaces, we've started looking at the first ways to kickstart interoperation. VR is an amazing tool for modeling, and Meta Horizon Worlds users have created some stunning creations using the precision you can only get from sculpting primitives in VR. Looking at this through the lens of interoperation, we wanted to allow these primitives not only to be used in Creator, but portable between either title in the future. Creator has just released support for primitive building, and it's using the same data model as Meta Horizon Worlds in order to process them. We're currently looking at ways we could enable these creators to build their creations to either platform. And having this compatibility at its core is going to make this exercise much easier. Primitive modeling is the thin end of the interoperation wedge, and we are continually working on ways to expand the reach for creations on both Meta Horizon Worlds and Creator. Here's a couple of examples of test environments, built in VR, using Meta Horizon Worlds, but now running directly under Creator.
Thanks, Andy. So what's our takeaways today? There will be an increasing number of ways you can start to build towards interoperability as a developer with tech from Meta. If you're a developer interested in enabling avatars in your product, you should check out Jolly and Webb's talk on our Meta Avatars. It's in the Innovate Responsibly track, and it's called Embracing a New Identity, Integrating Meta Avatars into an Already Established Product. If you're a current or potential creator on Meta Horizon Worlds, or Creator, we're working hard in the background with a goal to expand both the reach and interoperability of your creations. Or just dive in and take a look at the Meta Avatar SDK using this QR code. We want you to go out there and build more amazing creations across the metaverse.
Hi. I've been making games for more than 20 years, and in all that time, I've been fascinated by games characters and avatars. The reason for this is because I believe that if you do it right, nothing works better than a game character as the magic bridge that leads people into the virtual worlds you build. I'm Jolyon Webb, and I'm the head of technical art at Unit 2 Games. We're a meta game studio based in Leamington Spa in the UK, and this talk is about how a small team of our technical artists and engineers worked to integrate meta avatars into our existing games platform, which is called Crater. Crater is a free games making environment released in 2020. Crater's aim is to democratize game making. And so the heart of Crater is all about user-generated content and enabling new game makers to express themselves and collaborate together. We've built up a highly engaged community who've made thousands of wildly different and inventive games. So let's have a quick look at Crater and show some of the Crater avatars. From the start of Crater, our three key values have been to build community, collaboration, and creativity. These three values really do need to be at the heart of any platform that's going to focus on user-generated content. And also, these values work as a general manifesto for metaverse experiences. So, welcoming meta avatars into Crater was exciting. Enabling a meta avatar to jump into our platform to explore and create felt totally like what we imagined the metaverse to be. And it supported our three key values. New avatars help build community. A larger community builds collaboration. More community and collaboration is a great environment to allow creativity to flourish. The appeal for building a bridge to bring meta avatars into Crater was clear. But the team had some questions. There were visual fit and feel questions. The style for Crater and meta avatars is different. How would the meta avatars fit and feel in the Crater worlds? There were engineering questions. What were the steps to bring the meta avatars into a different platform? Let's explore the visual fit and feel first. The Crater and meta avatars are different, and that completely makes sense because they were designed separately to serve different goals on different platforms. Meta avatars have a focus on self. Their intent is to let you authentically represent yourself. This self-expression has lots of opportunities for customization through clothing and accessories, and these options are based in realism. So, the user's self-expressed identity is rooted in the real world. The Crater avatars have less of a focus on authentically representing yourself. Their intent is more about transformation. This is a cosplay or a gamey expression of self, with the option to move totally away from a real-world self to become a robot or an alien, for example. As game developers, we had a good understanding of transformative avatars. An avatar that's an authentic expression of self, though, was quite new to us. To get a feel for these new avatars, we did something really simple. The team created meta avatars, and we started running our morning stand-ups in Meta Horizon workrooms. This taught us a lot. We began to really identify with our own meta avatars and to recognize the other meta avatars we saw in the meeting as our real teammates. As early tests began to work and we saw the team's meta avatars appear in Crater, we felt that same sense of recognition. This was a new type of identity for us in Crater, and we valued it. Looking Looking at the technical questions, the Creator platform and the Meta platform are different. However, under the hood, we found there are also a lot of commonalities between the avatars in Creator and Meta. This meant we were able to use the Meta Avatars SDK and successfully work with its functionality to integrate the Meta Avatars into the Creator platform. This put the Meta Avatars right into the heart of the Creator worlds. We'd wanted to welcome the Meta Avatars into Creator and to have them live great lives there, to run, jump, climb, explore, and fully interact with the new worlds. This is what the results look like. We were really pleased with how Meta Avatars in Creator have turned out and how well we felt they fitted into the world. We were also pleased with how our key value of building community was supported. Adding Meta Avatars really has built another bridge to welcome a larger and more varied community into Creator. Creator's two other key values are building collaboration and creativity. With the Meta Avatars welcomed into Creator, they can join in and collaborate and create as game makers and world builders there. Here's an example of Meta Avatars building a world in Creator. From the start in Creator, the team has always looked at ways to maximize the avatar's expression of personality through emote animations and themed spawns into the world. The Meta Avatars in Creator share this functionality. Let's have a look. So, bringing the new look and identity of Meta Avatars to Creator has enriched Creator. The effort has been totally worth it, and it's been a lot of fun. The one key piece of advice I would give is this. If your team is thinking of integrating Meta Avatars into your product, start using the Meta Avatars yourself first. It's absolutely the best way to learn about their appeal and potential. As I said at the beginning, I believe avatars act as the bridge to pull your audience into the virtual worlds you build. But in the past, I've been used to doing this with one avatar type per platform. One avatar type equals one bridge. It's been super fun to learn that you can actually build more than one bridge to your worlds. And welcoming the Meta Avatars into Creator has done exactly this. The Meta Avatars gain the freedom to explore and create in a new platform, and avatar variety and community grows within Creator. This cross-platform travel really does feel like a metaverse experience, and it's happening soon. We really hope you'll be part of it, and that when we release, you'll take your meta avatar and jump into Crater. We would love you to try it out and hope that soon we see you out there exploring and making games in the metaverse.
Metaspark is our platform for building the augmented layer of the metaverse. Today, we're launching a beta for creating a new type of AR experience in Metaspark Studio, virtual objects. Hi, I'm Lucia Tahan, and today I'm going to be showing you these new virtual objects, how they work, and how to create them. Virtual objects will populate the world around us. You'll be able to place them on surfaces across your home or office to access unique functionalities or to make the space feel more personal. They can be as simple as an interactive 3D asset, or as complex as a full-fledged game or virtual assistant. Virtual objects are a building block of the augmented layer of the metaverse. They contain logic and can interact with the real world. Virtual objects can serve a multitude of purposes. They can be utilitarian, like a clock, inspiring, like a piece of digital art, or entertaining, like a game. They can be tokens that remind you of people, or be a variety of other things that change the way you interact with the world around you. Once you create virtual objects, you'll be able to test them through the Metaspark Player app, which is also launching in beta today. The new Metaspark Player app allows you to test virtual objects on the MetaQuest family of devices to better approximate future AR glasses. This is particularly true on MetaQuest Pro, our newest device, which has color pass-through. Let's get started with creating your first virtual object. Those of you who are familiar with AR might be wondering, what's the difference between virtual objects and 3D models or effects? Well, virtual objects are a route towards standardizing content for AR, a first step towards interoperability. They can coexist with other virtual objects in the same scene, even if they are created by different people. This is enabled by the virtual object ports or inputs and outputs. These ports allow the virtual object to receive information about the world and other objects, and to inform the app about its state or actions. Blocks in Studio are similar, but you can customize their inputs and outputs. This customization, though, makes it so that blocks cannot coexist between different creators in the same application, since there are no standards in how they can interact. Now that you have a general understanding of what a virtual object is, I'm going to show you how to build a virtual object in Metaspark Studio and how to test it in the MetaQuest Pro. You'll be making the timer shown here. First, we're going to open Studio, and right on the welcome window, you'll see a tile to create a new virtual object. Virtual objects are represented by an icosahedron icon. This is the new window to create virtual objects. On the left, you can see the scene tree with the virtual object node. On the inspector, you'll notice that we have a list of inputs and outputs that are available for virtual objects. They also show up in the patch editor. You can manage them and add more by clicking on the More Ports button. This brings up the picker with the virtual object port sets, which we call interfaces. For now, we only have core and activation, but plan to have more as virtual objects gain new interactions and capabilities. We are also introducing new features in the simulator to help you create virtual objects. It now has the same aspect ratio as the new Meta Quest Pro. And we have added interactive environments where you can simulate virtual objects. There are 6 spaces, including indoor, outdoor, domestic, and art exhibition spaces. They represent a variety of places where AR could appear in the metaverse. You can navigate around them and toggle them between day and night to test different illumination settings. You can also use them to test plane tracker and world AR effects. Let's start building the timer virtual object. First, you can import the timer model and put it in the scene. Now, let's look at the first input, show. Show is a pulse that the AR application will trigger when a user places the object in the scene. It tells the object to appear and expects a transition or animation. We want to connect an animation with this pulse so that the timer will have a nice scale-up effect when it is placed. To do this, you can connect an animation patch and a transition patch to the object scale. This will make the object appear in the scene by changing its scale from 0 to 1. You can click the Show input in the inspector to test that it works and to view the animation. The next input we want to connect is Hide. This pulse will be triggered whenever the application wants to hide the object with a transition. It's possible to reuse the same animation we have already used, but scaling the object down until it disappears. For this, you can connect the hide input to reverse in the animation patch. If you click the hide pulse in the inspector, you'll be able to see the virtual object scaling down to disappear. Next, you can connect the show complete and hide complete outputs. These ports will send the information to the AR application that the virtual object has completed its transition to its shown and hidden states. For this, you can create an option switch and an option sender that receives pulses. That enables you to send the animation's complete pulse to both virtual object outputs. You'll need to connect the show and hide inputs as well as the complete pulse from the animation to the option switch and sender patches. The remaining ports of the core set, show instantly and hide instantly, need to be connected with an animation that literally lasts 0 seconds, so that the virtual object can be shown in its full form immediately or hidden without any transitions. We recommend that you always connect all virtual object inputs and outputs. That will make your virtual object complete and ready for future AR applications that may use it in different ways. You can learn more about connecting inputs and outputs in the virtual object templates, as well as in the documentation. In the next section, you'll learn how to use the activation set of inputs and outputs. Finally, over in the inspector, you can click the ports icons to check that all the ports are working well. Now you can send the virtual object to the Meta Quest Pro. Very exciting. You should make sure that you have Meta Spark Player installed on your Meta Quest Pro and that you have connected it either with a cable or over Wi-Fi. Once connected, it will show here in the testing panel. You could even share this with another creator or collaborator by creating a link, but for now we're just going to send it to the device by clicking Send. And here it is on Meta Spark Player on the new Meta Quest Pro. You can place it on the desk and you can scale it using the controllers, you can move it, and you can change its elevation. Using the left-hand controller, you can test the virtual object inputs, including show and hide. Now that we understand the foundations of creating virtual objects, what's the next step towards making an interactive object? Here to explain is Rodrigo Castiel. Over to you, Rodrigo.
Thank you, Lucia. Hi everyone, I'm Rodrigo and I'm a software engineer at Metaspark. I'll be showing you how to build a slightly more complex and dynamic virtual object. That is, we'll be adding interactivity and animations through Patch Editor, or visual programming language. We first cover how to import and use textures, materials, and other assets to animate your virtual object. Then, you learn how to use Patch Editor to define its behavior and to integrate the logic with animation and user commands. At the end, we test our virtual object on Metaspark Player. Let's build this digital timer together. To make it fun, the timer will start the countdown only when it's activated via user input, and then it would explode once it reaches 0. Upon explosion, the state should be reset. We can model this via 2 states: idle, when the timer is blinking and waiting to be activated, and active, when the timer is counting down to 0 and exploding. We'll start from a half-baked project containing some pre-imported 3D objects, materials, and the explosion animation. Before we start working on it, let's briefly go over what we currently have in this project. On the right side of the window, we have the Activate Input port, which will be used to trigger the timer countdown. This input is part of the activation interface, and it's supposed to send by the controller layer when the user is interacting with a virtual object. On the bottom, notice that we already have a patch editor graph that uses loop animations to move and rotate the individual fragments of the timer once the explosion starts. In its current state, though, the timer doesn't display any digits, nor does it respond to user inputs. On the left, you can see some scene objects and assets. The 3D objects are assets that we have instantiated into the scene object panel on the top left corner of the window. They can be broken down into 4 components: the back, the front, the display, and the digits. The digits and the display share the same materials. They're named in the format MMSS, where the uppercase letter indicates which digit it refers to. Changing this material will affect its corresponding scene objects. So now let's begin our work by making the timer display some numbers. As mentioned previously, the 3D assets are made up of fragments that can be pulled apart by applying different transformations. However, they also have mesh groups that can display textures separately. If the texture represents an LED number from 0 to 9, we can change it to display digits. Therefore, each digit object points to its corresponding material, and each material points to a number texture. We don't have those textures yet in the project. To import them as a sequence, we can click on the plus button and choose Import Texture Animation. We can then choose the 10 number PNG files. Here we use the suffix _n so that the texture frame will match its number. Once chosen, we simply click Import. This process will create one animation sequence, which can be used to choose which frame, that is texture, we're displaying at a given moment. Since we'll need one independent animation for each digit of the timer, let's create 3 more sequences and rename them to match the material names in the MMSS format. Each animation sequence is linked to a texture sequence from which it will collect its frames. So we can simply select all animation sequences and go to the inspector and choose the timer digits textures that we just imported. Then, for each material, we'll choose the animation sequence that will be providing the texture to be displayed. Notice how the timer is now displaying random digits. How fun. That's because we're not yet specifying which frame should be picked by the animation sequences. To do that dynamically, we have to use the patch editor. Now, I'll give you a quick overview of patch editor. Patches are building blocks that can pass and receive different data types. Here, you can see the value patch, which receives and produces a number. Numbers can be used in math operations or to define a logical flow or even states. They can also be used to control animations or to scale objects. This is the Boolean version of the value patch. A Boolean data type is simple. It can only carry a value that is either true or false. We'll be using it to specify whether the timer display is on or not, which gives us the blinking behavior. Another important data type is the pulse. A pulse is an instantaneous signal change emitted when something happens. For example, when the user activates a virtual object, a pulse is emitted. Well, if you're wondering what are those yellow patches, those are consumer patches, and they are associated with assets and objects from your project. When you instantiate them into Patch Editor, you can dynamically change properties of your animations, textures, and other types of objects. Our next step is to create a patch graph to set the digits of the timer given the remaining countdown time. For example, if there's 67 seconds left, we should display 0107. In order to choose which texture sequence frame will be displayed, we will instantiate the current frame property as a consumer patch. Notice that all the digits now become 0. We know that converting seconds into minutes and seconds requires computing multiple integer divisions. Although we have built-in patches for division and modulo, reusing them multiple times will be repetitive and tedious. So I'll now show you how to create a patch group asset that can reuse to improve this process. To create a patch group out of your selected patches, you can simply right-click one of them and select Group. Now all patches are hidden inside this new group. The next step is to expose patches within the group via its input and output ports. You can do so by right-clicking on the group and selecting Group Properties. In this case, we'll create inputs and outputs for the numerator, the denominator, the quotient, and the remainder, all of which have number as the data type. Once the ports are added, if you enter the group to edit its patches, you'll notice that there are now magenta and yellow patches representing the input and output ports. So let's simply connect the output patches representing the quotient and the remainder, and the input patches representing the numerator and the denominator. Now our patch group is complete. If you convert your patch group into a patch asset, every instance of the patch asset will be automatically updated if the original patch group changes. With improved division and modulo patch asset completed, we can use it to calculate how many minutes are contained in a given number of seconds. The following patch graph computes which decimal digits should be displayed by just doing some basic time conversion math. Here's a bonus patch graph to make the display blink if needed. If the blinking is off, then it should always be set to visible. You can read more about its patches in our documentation. Now that you learned how to create a patch group, let's build together another patch group to store the logic of the timer. The idea is that it will have 3 inputs: enable, reset, initial value, all represented by magenta patches. This patch group will also have 2 outputs: timer value and completed, the yellow patches. We combine a loop animation patch, which ticks every second, to increment the counter patch value. In order to calculate the remaining time, we use the subtract patch with the initial value. To trigger the completed pulse when the timer reaches 0, we compare it to -1, and when it becomes true, we generate the pulse with the pulse patch. In the current state, our timer is able to show digits, to blink when needed, to explode, and to count. However, those things are not connected. Let's see how we can integrate all of them, preserve the state of the timer, and use the activate port to change states. Here, we can use an integer value to hold the state, 0 for idle and 1 for active. To better organize things, we can use 2 equals exactly patches to give us booleans for is idle and is active. We will be connecting them with the timer state patch group we just created and the virtual object inputs. Let's now bring those patches closer to the flows we created before. If the state is idle, we can just connect it to should blink. To make the timer count, we have to enable it if the state is active. Then, to set timer digits, we connect the timer state output with the duration. Remember that the timer should reset its count once the state becomes idle. This can be achieved by generating a pulse once the is idle output becomes true, and by connecting it to the reset port. Once the timer counts to 0, it sends a pulse completed. We can connect it to the animation patches to trigger the explosion. Now, we can use the delay value patch to pass the current state from one frame to the next via its receiver patch. The initial state is idle or 0. To preserve the state of the timer, we can instantiate the store value patch, which updates values once its input store is triggered. Then, we use the option picker to select the next state based on the current state. The next state should only be set once either activate is triggered or the timer is completed. Hence, we use a pulse merge patch. Last, we connect the activate input to set the next state to active 1 only if the timer is idle, otherwise it's ignored. This completes our timer. Let's now test our timer on Metaspark Player. Once it's been instantiated in the scene, we can select it and then click Activate with the left controller. This makes the timer start the countdown. You can move it around using the transform options on the right controller. Boom, the timer just exploded. so it works as expected. Thank you all for watching this session. As of Connect 2022, virtual object creation for Metaspark Studio can only be accessed through our beta program. You'll need to sign up to learn more and get access. You can also watch our other Connect session, building advanced virtual objects with scripting and shaders, to learn more. We look forward to working with you and seeing what you build. Thank you.
Hi, my name's Austin Mobilov. I'm the product manager for developer tooling on Metaspark, our platform to enable creators and developers to build for the augmented layer of the metaverse. You may have learned in our other session about Metaspark Studio, our awesome tool for building augmented reality experiences, which includes a powerful visual creation flow, and virtual objects, one of the building blocks for the augmented layer of the metaverse. If not, you can check that session out in the links below to get a more in-depth understanding of what virtual objects are and how you can sign up for the beta program to start creating them. In this session, you'll learn how you can make more intricate and interactive virtual objects with code. We'll cover scripting, using TypeScript to define interactions for the virtual objects you build, shaders, using our dedicated shader language, SparkSL, to add more control over the rendering in your virtual objects. And finally, debugging, using our extension for VS Code to help debug your scripts. For this demo, we're going to create an interactive virtual object in the form of a timer, which can be placed on your home desk with Metaspark Player on MetaQuest Pro or other devices in the MetaQuest line. We'll show you how we've used scripting and shaders to enable a user to tap on the timer to increase the time by increments of 5 seconds. And if there's been no input for 3 seconds, the timer will start to count down with a pulsating effect. Once the timer reaches 0, it will explode into several pieces to catch the user's eye. To save time, we've already set up a basic project in Metaspark Studio with the assets needed for this demo already in place. Now, I'll hand over to Dunfan, who will give you a quick overview of the project and assets we're going to use. He will then show you how he used scripting and shaders to create an interactive timer before revealing the finished virtual object in Metaspark Player.
Hello, my name is Dunfan Liu. I am a software engineer in Metaspark. Today, I'll be showing you how to use scripting and shaders to build a timer virtual object with a dramatic touch. Before we dive into the code, let's have a quick look at the project setup in Metaspark Studio. Inside the scene, we have an object named timer, and it's composed of 3 child objects: front body, back body, and digits. The front body object is a plane that sits in front of the digits. It is mostly transparent at the rest state, but later on, we will use shaders to make it light up. The back body is a color plane that sits at the back, whose color is also controlled by custom shaders. And digits consist of 5 additional child objects, including A, B, C, and D for each of the 4 digits from left to right, and a colon in the middle. Each of the aforementioned objects has its own material. So we have a front body material, a back body material, and 1 material for each of the digits. The front and back body materials are of the type shader asset, meaning that the materials are backed by some shader code. The materials for digits are of type flat, which is a simple built-in material type. The time displayed on the virtual object is determined by the texture applied to each of the digit materials, which is in turn controlled dynamically by a scripting. Let's have a look now at how that is achieved. We will use a TypeScript program to control the behavior of our timer. The script governs the internal state of the timer and controls the material properties and transformations that reflect this state. We begin with this timer state enum. The timer transitions between 4 different states. A rest state, for when the clock isn't ticking and the user is able to update the timer limit. A ready state, which is when the time limit has been set, but the countdown hasn't started. A ticking state, for when the clock is counting down. And finally, an exploding state, for after the timer counts down to 0 and explodes. The timer state is used as a property of the timer class, which additionally keeps track of the current value of the timer as well as the time limits. Besides the timer state, the timer class also keeps handles to the scene objects which we just saw in Metaspark Studio. We have the timer object, the material handles for the body and the digits, an array of textures for the numbers 0 to 9, and some animation clips and controllers. The scene handles are created in the getHandles method, which we show on this slide. Handles are created using a string representing their name, and is returned from a promise. The scene handle gives our script the ability to control the appearances of objects in the scene. As an example, when the timer is counting down, the digits displayed by the virtual objects need to update on each second. This is realized by the update timer class function shown here. For each of the 4 digits A, B, C, and D, the function computes the digit between 0 and 9 that should be displayed at this slot, and retrieves the texture showing that digit. The texture is then applied to the material corresponding to the digit slot. We've seen how to update the digits on the timer, but having numbers that change isn't all that exciting. Next up, we'll add color variations to the timer to indicate the change of state, and provide feedback for user inputs. We will implement 3 color variations. On the left, we have the green pulse of light that gets emitted when the user increases the time limits. In the middle, we have the color transition from blue to orange when the timer enters the ready to count down states. On the right, we have the accelerating red pulse that accompanies the timer's ticking. To implement these color variations, we will use shaders. In our shader code, we begin by assigning a tint color for each of the possible states of the timer. The tint will be the dominant color of the timer in that state. For the resting state, we'll use blue. For the ready and ticking state, we'll use orange. And in the exploding state, we'll use red. Spark's VS Code extension recognizes that these vec3 values are colors and displays a small color indicator next to it. If you click on the color square, you'll even get a color picker that automatically updates the vec3 values for you. The shader takes as input the state and the float named transition, which is a signal varying from 0 to 1, indicating the progress of the state transition. The shader also receives an optional texture as input, which defines the color pattern applied to the timer. Also, since this is a fragment shader, we'll declare color as an output. Inside the main function, we begin by sampling the base color texture. We do this by first retrieving the UV of the current fragment, which we write as fragment of getVertexTextCoord, meaning that the UV is an interpolation of vertex texture coordinates onto individual fragments. We sample the texture using this UV, and since we have an optional texture, we provide a fallback value using value OR. We create a temporary variable alpha, which stores the alpha channel of the sampled color. Then we call the getTint function previously defined to retrieve the dominant color of the current states. In order to implement the aforementioned color variations, we modify the tint based on the state of the timer and the transition progress. For the first animation, we implement the light pulse as a circle with increasing radius and diminishing brightness. The implementation uses an SDF circle function, which is part of SparkSL's standard library. The cool thing about the SDF circle function is that given the circle's center and radius, it returns another function which can be applied again to produce a vec2. That is a higher order function in a shader. The SDF value is used to compute the strength of light pulse at the current pixel, which we use to mix the tint and alpha values. Then we have the other 2 color variations. For the transition from blue to orange when entering the ready state, we'll simply use linear mixing. And for the red pulse that is sent when the clock is ticking, we'll use another SDF function with respect to a moving rectangle. Now that the tint has been computed, it's time to compute the final color. We could just use the tint as the final color, but doing so will lose details, such as the lightness variations from the original texture. For this reason, we need a function that, given a base color and the tint, applies the tint to the base color while preserving lightness. We could create a function that does this in this shader, but in fact, since this function is quite possibly reusable, it would be more scalable to create it in a different shader module. SparkSL supports linking multiple shader modules, each of which sits in its own .sca file. For this utility function, we'll create a module named colorUtils and create a new namespace called colors. Inside this namespace, we implement the applyTint method and mark it as export, so that the other shader modules can use it. The applyTint function converts the RGB values of the base color and the tint color into HSL color space, and combines the hue and saturation of the tints with the lightness of the base color. Notice that this colorUtils module also imports another module called colorSpaces. This is a SparkSL built-in module that provides standard functions for color space conversions. Going back to our main shader, we import this newly created colorUtils module and call the applyTint function under the colors namespace to obtain the final color. There is a small edge case here. If the base color is fully transparent, it will usually have RGB color 000. In this situation, it's better to return the tint color directly. And this wraps up the shader code, and we'll move on to see how the scripting code passes the necessary state and transition signals to the shader. The TypeScript code passes data to the shaders by handles to the body materials which use those shaders. This is done by invoking the setParameter method of the material handles, which we do here in the setBodyMaterialParameter function. In the timer class, we already have a setState method, which is used to update the state property within the timer class. So we'll add a call to setBodyMaterialParameter here so that every state change is also synchronized to the shader. In addition to the state, the shader also requires a transition signal generated via the getTransitionSignal method here. This method receives a duration in milliseconds and creates a linear animation signal from 0 to 1 within this duration. To send the transition signal, all we have to do is call getTransitionSignal once to get a signal and call setBodyMaterialParameter once to upload it. The value of the signal is automatically updated by the animation driver and then synchronized to the shader on each frame. We have now completed the code needed for the color variations. But I'd also like to build some tension for the final explosion. And I like to do that by adding an increasingly stronger oscillation to the timer. This can be implemented in the vertex shader, but another great way of doing it is via the Spark Entity Components experimental package in the AR library. This package provides reusable components and an in-frame API. In the script, we will create a component called Oscillation Component. The component will have two properties, including a magnitude for the oscillation and a transform component, which this oscillation component will manipulate. The transform component is created in the onCreate method, which gets or adds a transform component on the same scene entity that the oscillation component is attached to. To actuate the oscillation, we implement the onFrame method for the component, which will be called everyFrame. We compute a sinusoidal displacement in each of the x, y, and z directions and apply it to the transform component. We now need to attach an instance of the oscillation component onto the timer. We add a property in the timer class, and within the getHandles method, we create a scene entity for the timer. And then we create an oscillation component attached to that entity. To control the magnitude of the oscillation, we simply update the magnitude property of that component. As an example, in the onTick method, which gets called every second during the countdown, we compute the progress of the countdown and update the magnitude accordingly. At last, we arrive at the grand finale where we implement the explosion effects. There are two parts to this. Firstly, we explode the timer when the countdown gets down to 0. And then we reassemble the pieces back to a timer so that it can be used again. Though it looks complex, the explosion effect is extremely simple to implement in code if you have the animations baked as ready-to-use animation assets. For our virtual object, we have two animation clips, one for the explosion and one for the reassembly. And all we have to do is use Spark's API to ask the animation controller to play these clips. That's it. And that's how you use code to create a cool explosive timer. The virtual object can now be mirrored to the MetaSpark player, and this is how it'll look. You can see the color variations as the timer state changes, the shaking of the timer as it counts down, and of course, the explosion at the end. It is great to see the timer virtual object fully functional after all of our hard work. Creating virtual objects through code is fun, but it can also be frustrating when there is a bug. Luckily, we have the MetaSpark Studio plugin for VS Code, which comes with a debugger. All you have to do is download the plugin from the marketplace and enter the Run and Debug panel and click the Run button. You can then add breakpoints, inspect variables, step in, over, and out. And now you know how to build amazing virtual objects with scripting and shaders. We look forward to seeing what you will create.
Thanks for spending time with us today to learn how you can make more intricate and interactive virtual objects with code. As of Connect 2022, virtual object creation for MetaSpark Studio can only be accessed through our beta program. You'll need to sign up to learn more and get access. We look forward to working closely with you to continuously innovate, build, and test new virtual object functionality.
Hi, I'm Jacob Rossi. I lead our product team that brings the web into VR and the metaverse. Like the physical world, in the metaverse, you want access to the web's virtually infinite information and services at your fingertips. And web developers want to be able to build for this new frontier. Today, I'm excited to share a number of new capabilities on both of those fronts that will advance how users experience the web and how developers build for the metaverse on the web. The web, as a platform, is well positioned for the metaverse. The metaverse is a successor to the mobile internet, and the current internet already has characteristics similar to that of the metaverse, like virtually infinite destinations, the ability to visit or share a destination quickly with links, and an open and interoperable platform for developers. New industry standards like WebXR are enabling immersive metaverse experiences in VR that work across other devices as well. So, let's take a look at how we're advancing the state of the web in the metaverse through MetaQuest. On MetaQuest, we provide three fundamental technologies for the web in the metaverse. MetaQuest Browser, one of the most used apps on MetaQuest, and your portal to all the web has to offer. Progressive Web Apps, or PWAs, the developer framework that enables web developers to build apps for the MetaQuest store that are installable by users to their library with rich multitasking by default. WebXR, an innovative industry standard that gives web developers the power to build fully immersive experiences for the metaverse and leverage the power of the hardware. Let's start with MetaQuest Browser. It's no surprise to me how popular the browser is on MetaQuest, as it puts the internet with its billions of pieces of content at your fingertips. You can use it for information, entertainment, socializing, learning, and productivity. Today, the browser and PWAs are only available in your home environment. But just like the physical world with our phones, You want easy access to the web's virtually infinite information and services wherever you are in the metaverse. That's why we're announcing support on MetaQuest Pro for using browser and PWAs anywhere in VR. MetaQuest Pro users can pull up a browser using its overlay technology. So you can read a message, check your calendar, look up tips to beat that tricky game level, and much more without leaving the VR app you're in. And this is made possible through the expanded 12 gigabytes of RAM on MetaQuest Pro. Now, the web's wealth of information is incredibly useful in the metaverse, offering valuable entertainment, socializing, productivity, and learning opportunities. But we also know that for parents, the web can present risks for your teens. That's why we're proud to announce new and improved parental supervision features for MetaQuest Browser. In addition to the ability to block the browser entirely, which we launched earlier this year, parents will be able to enable category-specific content filters to choose what type of content is appropriate for their teen. And soon, parents will also be able to customize content filters by allowing or blocking specific website domains, including ones requested by their teens from their headset. This will give parents the tools to help their teens enjoy the web safely in the metaverse. And that's important because the web has so much to offer. Of course, not just for users, but developers too. MetaQuest's up-to-date support for web standards, including immersive technologies like WebXR, allow web developers to build for the metaverse. Last year, we began to enable web developers to publish web apps directly to the store, using industry-standard progressive web apps, or PWAs, so that users can discover their apps and install them to their library like any other app in VR. Since then, we've enhanced the multitasking support for PWAs, we've made input easier, such as mouse wheel emulation via the controller thumbstick, and we've improved performance, all of which make PWAs even better on MetaQuest. One of the exciting aspects of PWAs is just how easy they are to build, especially if you already have a modern web app. But we wanted to make them even easier to build. That's why we partnered with Microsoft to bring MetaQuest support to their PWA Builder product, a popular developer tool for creating PWAs that work across a variety of devices and stores. Here to tell us more about PWA Builder support for MetaQuest is Microsoft's Josh Satch.
Thanks for the introduction, Jacob. Let's dive right in. PWA Builder is a full-featured developer suite that helps web developers be successful in the progressive web application space across phones, PCs, and now even VR. Our team has built out extensive tooling and resources to make sure that web developers can easily and seamlessly leverage all of the amazing aspects of PWAs. Since the project's genesis in 2012, we've helped all types of developers, from multinational development teams to students, helping them learn, build, and package their PWAs for the various app stores. Since then, we've activated over 500,000 developers worldwide and continue to strengthen the PWA developer community. This past year, our team has made some very exciting announcements. We are very excited to share with the developer community our VS Code extension that supercharges PWA development right in the developer's code editor. PWA Builder Studio has received an amazing reception from the developer community and is quickly becoming one of the most powerful and popular tools for PWA developers. One of the greatest value features of PWAs is their inherent cross-platform reach. That's why we're so happy to partner with Meta to bring the power of PWAs to MetaQuest devices. Developers can now use the PWA Builder site and VS Code extension to generate packages for Windows, Android, iOS, and now MetaQuest devices. Packaging your existing PWA is quick and intuitive using our tooling. Let's walk through packaging a PWA for the MetaQuest platform using pwabuilder.com. Head to your browser and go to pwabuilder.com and enter in the link to your PWA in the text bar. For the purposes of this demo, I'll be using webboard.app, a whiteboard application. Once PWA Builder analyzes your URL, you'll be sent to the report card page where you'll be able to see what aspects of your site need to be improved. You can then package for the various platforms and build great app experiences for your customers. In our case, webboard.app already has a manifest and service worker and meets security requirements. So we will just click on the package for store button over here. Woohoo! Congrats! We've made it to the packaging modal, where you can generate packages for your PWA for Windows, Android, iOS, and MetaQuest. Let's go ahead and click on the Store Package button in the MetaQuest section. Lastly, take that package generated from pwabuilder.com and load it into your developer-enabled MetaQuest device. For more instructions on how to sideload a PWA onto MetaQuest devices, scan the QR code. So what are you waiting for? Head over to PWA Builder now to start your PWA journey.
Thanks, Josh. Our support for PWAs is still early, but having great tools like PWA Builder makes it easy to build for MetaQuest. We already have a number of great apps with more and more on the way, like Dropbox, Adobe Acrobat, Coursera, and Peacock. With lots of apps and websites at your fingertips, that also means lots of usernames and passwords too. If you're like me, you've got hundreds of accounts on the internet, and remembering your usernames and passwords is a challenge. Wouldn't it be even better if in VR you could access the passwords you already had saved on other devices? To do that, we're excited to announce we're working with LastPass, a market-leading password manager. We're honored to have Kareem Tuba, CEO of LastPass, join us to share more about how they're simplifying and securing logins everywhere, including the Metaverse.
Thanks for having me, Jacob. We're thrilled to be here partnering with Meta, and we're really excited to be launching LastPass as a PWA in the MetaQuest store. And in early 2023, we'll be natively integrating LastPass into the MetaQuest browser for seamless access within your VR experience. Like me, you have hundreds of accounts that are critical to how you work, live, and play online every single day. When access gets disrupted or isn't available, it can be pretty frustrating. With this new LastPass integration, your entire digital life is right there within reach. You'll be able to securely access the logins you need to experience the Metaverse, whether you're playing games or collaborating with virtual colleagues, all without taking your headset off. With the new LastPass Vault on your MetaQuest device, you have simple access to all your passwords, credit cards, addresses, and much more. All secure by design using our zero-knowledge security model that keeps your data encrypted and safe. In LastPass, you can scroll through your most common sites, select the credentials you want to copy, and simply paste them where needed so you can log in without ever having to type in a password. Whether you're logging in or completing a purchase, this is the simplest and most productive way to get into your apps for easy, secure browsing while in the Metaverse. This will be available in the MetaQuest store, and we'd love for you to check it out and share your feedback with us. Even more exciting, early in 2023, we're actually making this experience more seamless. And we're doing that by integrating LastPass into the MetaQuest browser that Jacob mentioned earlier. You'll be able to automatically save and fill items into your LastPass vault directly from the site you're visiting in the Metaverse. Universal access to your logins, personal information, and data should be a given, no matter which device you're using, and LastPass provides that ubiquity, whether you're at home, at work, or in the Metaverse.
Thanks, Kareem. Having LastPass in VR is really going to make accessing apps and information in the Metaverse easier. The opportunities for the web in VR don't just stop at 2D sites and PWAs. With the power of WebXR, web developers can build powerful, immersive experience for MetaQuest 2. The new tab page of MetaQuest browser features fun, powerful, and engaging experiences built using WebXR. And as always, if you have a great experience you want featured in the new tab page, head over to developer.oculus.com/WebXR to submit your content for consideration. And today, I'm excited to announce an all-new type of immersive experience you can build on the web for MetaQuest: mixed reality. Web developers can take advantage of high-resolution, full-color pass-through on MetaQuest Pro to build immersive content that augments your physical world, opening up tons of new creative possibilities. Powered by Meta Presence Platform, sites in the browser, and PWAs in the store can enable pass-through, understand horizontal and vertical planes in your environment, and anchor objects to the physical world. We were so excited about the possibilities, we partnered with Foria Studio to build a technology showcase for MR on the web that we call Spatial Fusion. Take a look. Spatial Fusion is just a taste of what you can do with mixed reality on the web. You'll find it soon at spatialfusion.io and featured in the MetaQuest browser new tab page. MR for the web is possible through the latest WebXR industry standards. Enabling pass-through is as simple as requesting an immersive AR session for WebXR. Using planes from the scene is also easy. Just query the detected planes property of the XR animation frame, and you'll get the planes of the Guardian walls, ceiling, floor, and any furniture like couches or desks that the user has set up in their Guardian settings. And anchors are as simple as using the create anchor method of the XR animation frame and providing a pose and reference space for the anchor. One of the things that we improved was advancing the standard to support saving anchors locally, so that anchors can be persisted in a space over multiple sessions using MetaQuest. MR for the web will launch on MetaQuest Pro. But what's great is that we're bringing these capabilities to MetaQuest 2's pass-through as well. So you can build for all the users of MetaQuest 2 and enjoy the best experience on MetaQuest Pro. We'll have updated documentation and samples soon at developer.oculus.com/WebXR. Of course, WebXR can build VR experiences too, and we have exciting updates there. We're launching a developer preview of Project Flowerbed, a new VR experience for the web designed and built by Meta. Project Flowerbed is designed to showcase what's possible, develop best practices, and push boundaries on quality. Project Flowerbed is an immersive, meditative garden building experience. Choose your flowers and trees to plant, water them and watch them grow. Take pictures of your handiwork and return again and again to relax in the serenity of your creation. We're launching Project Flowerbed to help developers learn best practices for performance, interaction, asset optimization, and more. But you don't have to just be inspired by Project Flowerbed. You can leverage what we learned directly because Project Flowerbed will be open source. Check out DM Lau and Scott Nagy's talk, Build Great WebXR Experiences, for a deep dive on Project Flowerbed and the best practices we developed. Or if you just want to relax in your own virtual botanical garden, you'll find a developer preview of Project Flowerbed at the URL shown here, with the full experience coming soon. The web platform on MetaQuest offers developers advanced opportunities to build 2D, VR, and MR experiences for the metaverse. For users, MetaQuest Browser provides at your fingertips access to information, services, and immersive destinations in the metaverse, now available on MetaQuest Pro from inside any VR app. PWAs make it easy to discover and save the most important 2D and immersive web apps to your MetaQuest library. And WebXR brings VR and MR capabilities to the web, including new advancements on MetaQuest Pro. To get started, launch Browser on MetaQuest and try out the developer preview of Project Flowerbed today, Spatial Fusion in the coming weeks, or any of your favorite websites. And if you're a developer, head over to one of the URLs on the screen to learn how to make your existing sites work great in MetaQuest Browser, how to build a PWA for MetaQuest, or how to build VR and MR experiences using WebXR. The Metaverse is an exciting new frontier, and the web will be front and center in that endeavor. We're excited to see what you build for it.
The MetaQuest browser is a powerful and flexible platform for immersive XR experiences. Open standards like WebXR, WebGL, and GLTF enable developers to create and deliver high-quality XR apps, and only a hyperlink is needed for users to start using your app. However, for a developer, the tools and processes needed to build amazing WebXR experiences are different from the tools used to make most native XR experiences, and also different from traditional flat web authoring tools. I'm Scott Nagy, a developer on the MetaQuest browser team, and I'm going to share what we think are some fantastic tools to supercharge your creation of great WebXR experiences. I'll also be talking about an immersive case study WebXR experience that we've built to showcase how to create high-quality WebXR apps. We're calling this experience Project Flowerbed. Here's a quick peek of it running in the MetaQuest browser. We're releasing a preview version of Project Flowerbed today, and you can load it up in a WebXR-capable browser and try it out. The QR code that you see has a link that will take you directly to the app. Later this year, we're going to open source all of our code and content that went into Project Flowerbed, so folks can explore what we've done and learn from it. We're also planning to release a more polished version of the app later this year. Okay, when we want to build something like Project Flowerbed, how do we do it? Today we're going to cover 3 key aspects of developing a WebXR app. First, what engine should we use to build this? Then, how do we create and process our content? And finally, what tools are available to help develop and polish our WebXR app? The first question most folks have when they start a WebXR project is, what engine should I use? Sure, you could write all your WebGL and WebXR and physics and whatever code from scratch, but if you're like most developers, you want to leverage an existing engine to accelerate your development process. For Project Flowerbed, we chose Three.js as our core rendering engine. Three.js is an open source Web 3D engine that has a huge community that has created a vibrant ecosystem of different components which layer on top of Three.js to provide things like physics, AI, or even path tracing and advanced rendering in any browser. Best of all, Three.js has first-class support for WebXR in the engine, which can be activated with a few lines of code. We chose Three.js for Project Flowerbed because of its flexibility as well as its community. Because Project Flowerbed is a case study app for WebXR and the MetaQuest browser, it was important for us to build on top of a community-driven engine like Three.js so that we could really understand how other developers are building their experiences today. Three.js isn't the only WebXR engine option. Some other engines to consider include Babylon.js, a TypeScript-based engine that comes with some cool built-in tools like a scene inspector, or PlayCanvas and the Wonderland engine, which both offer editor-based workflows similar to traditional game engines. Unity also has an option to export a project for WebXR, which is a good way to get existing content from Unity onto the web. The web-based engines like Three.js and Babylon.js are flexible and powerful foundations for WebXR apps because they're written specifically for the web platform. They integrate well with web development tools and workflows, and are focused on efficiently packaging and distributing content and code over the internet. Getting back to Three.js and how we used it. Three.js is built for the web and focused on rendering, and is designed to be composed with other modules to deliver the specific functionality an app needs. You can either assemble these components piece by piece, or use a framework which provides a more complete set of functionality to build an app. A-Frame is a popular framework which adds a fully declarative structure on top of Three.js. This lets you author HTML-like content that shows up as a 3D scene, and provides an easy way to immediately arrange some 3D content and display it in WebXR. React 3 Fiber is another popular option, which wraps Three.js as a React renderer, enabling developers to interface with Three.js through React components. This creates a really familiar environment for folks who are already experienced working in React, so they can start authoring 3D web content with the same paradigm. For Project Flowerbed, we decided to compose our own set of libraries together instead of using one of those frameworks. Because Project Flowerbed is an exploration of the 3D web ecosystem, we wanted flexibility to kind of mix and match pieces as we built it. For example, we wanted to use an entity component system architecture to organize our project in a performant way. So we use an open source ECS implementation to manage our objects and application-specific behavior implementations. To drive our physics and raycasting, we grabbed 3Mesh BVH, which implements a bounding volume hierarchy on 3 meshes, and gives us fast collisions and raycasts, and then we wrote our own layer on top of that to define interactions and responses to those collisions. We also used other components to help manage our custom materials, render immersive UI and controls, and run our positional audio system. These libraries all layer on top of Three.js, and kind of let us compose our own custom engine, and give us a great foundation for our app. Now that we've decided on our core technologies, we need to start getting some content to put into our app. Here's DM Liao, another engineer on the MetaQuest browser team, to talk about the content creation tools and pipelines we used.
Okay, now we have an engine and need some content. But what content exactly? You need some visuals for one, 3D models and textures, and you'll want some audio too, sound effects and music to make the experience more immersive. I'll go through all those in time, but let's start with the 3D models, because that's the vast majority of the content you're going to need. For Project Flowerbed, we use the GLTF file format to save our 3D models. The GLTF format is an open format that was designed to be the JPEG of 3D, and is strictly a delivery format, optimized for small file size and fast runtime processing by applications that use them. It enjoys out-of-the-box support on all the engines we talked about earlier, and most of the engines have viewers available that enable us to quickly see how our models render in-engine. Here's the same Squirrel GLTF from Flowerbed across GLTF Viewer, which was built on Three.js, Babylon.js's Sandbox, and Play Canvas's Viewer. The GLTF file format also contains a wide array of features that are useful for developers. Nodes, transforms and scene definitions, full PBR materials, skinned meshes, and morph targets, and if the core features aren't enough, it also supports extensions for custom needs. More material features like sheen and gloss, compression schemes, GPU-ready texture compressions, among others. And speaking of material features, Kronos' 3D Commerce Working Group is building GLTF extensions designed to enable more realistic and accurate materials for product renders. So great, that settles the model format. What about textures? They're just images, so you can use PNG or JPEG, right? Sure, you can, but we recommend using the KTX2 texture format. It is a texture transmission format that is specifically optimized for delivery and transcoding for rendering on the GPU. It's got a lower memory usage than PNG or JPEG at runtime, but a similar file size on disk. That means you can fit more textures into your GPU and also render them faster, because they render from a compressed format instead of the raw RGBA that PNG and JPEG have to expand to on the GPU. It's also got tunable compression support, of which there are two main types. The ETC1S mode is higher loss, but much lower file size, and the UASTC mode is very high quality and a higher file size to match. And regardless of which one you use, you can compress them even further with gzip. And so if there's anything you should take away from this talk, it's that KTX2 textures are great and should be incorporated into your asset pipeline if at all possible. Now that we've got the file format settled, how do we make all those models? There are a number of tools available, but for Flowerbed, we used Blender. Blender is a 3D modeling program, and it's free and open source, and natively exports the GLTF. We used it for everything from authoring individual objects to creating the entire environment for Project Flowerbed. Blender is very flexible and allows you to do a lot of scripting, which also let us use it as our level editor. We assigned custom properties to individual meshes from within Blender, which allowed us to attach JSON data directly to the nodes in the GLTF model, and then read those properties in Engine later to attach gameplay behaviors. So things like where ambient sounds would play, where to place props, which objects have colliders, they could all be defined from within Blender. We also used Blender scripting to generate some of those gameplay objects ahead of time. Shown here is a snippet of a script that we used to generate the colliders from the environment model. And that's pretty much the extent of the customization we did for Flowerbed, but Blender gives you a lot of tools and extensions to make custom behaviors for your own experiences, such as object linking and modifiers. And the scripting is very powerful, so you really can make your own sophisticated tooling on top of Blender if you need to. So, all right. After that, we were able to export the GLTFs from Blender and import them directly into Three.js. So that's that, right? Well, there's a bit more work to do. We still had to compress everything. Compress the GLTFs, then compress the textures, then make the KTX2 textures like we said everyone should do. For Project Flowerbed, we were looking at almost 700 megabytes of uncompressed models and textures alone, which is a lot to load on the web. Fortunately, there are tools to do all that compression and more. The ones we looked at are GLTF Transform and GLTF Pack. They are both open source command line tools that let you do extra processing on your GLTFs and textures, and handle everything that we've covered so far. We primarily used GLTF Transform for Project Flowerbed, but they both support a wide variety of workflows. Those tools take in a GLTF and produce a GLTF that has been compressed or has had unused nodes removed or any other processing you need. And that GLTF can then still be loaded in Three.js or any other web engine. However, since many of those compression schemes involve GLTF extensions, you have to be careful to make sure that you enable support within those engines for those compression extensions. KTX2 and GLTF compression is fortunately well supported, so getting them to work in Three.js was a matter of adding a few functions to turn on that support. At any rate, for Project Flowerbed, our model asset pipeline now looked like this. We wrote the pipeline that used GLTF Transform to quantize the meshes, compress them, convert textures to KTX2, resize large textures to further reduce file size. It was another step in the middle, but we found it well worth it. Having a programmatic content processing pipeline meant that we could run it and reprocess our GLTFs on demand and recreate them whenever we made changes, either to the models or to the pipeline itself. It let us fix bugs in our pipeline, fine-tune our compression settings, and automatically export all of our models to capture those changes whenever we updated them. And also, it was valuable for the file size and runtime memory savings. Let's take this rabbit model, just one of many in Project Flowerbed. The version that we exported straight from Blender was 4.1 megabytes, and running it through our processing and compression script brought it down to 2.3 megabytes, almost half the size. Now apply that through every single model, some more compressible than others, and we were able to shrink our whole bundle from the almost 700 megabytes to less than 200 megabytes. Still big, but much more reasonable for a full 3D web experience. Now, that pretty much covers all the visuals in the experience, but there is still all the audio. And audio is important. Having good sounds can make your experience that much more immersive. Like with models, we needed to figure out what file format to store our audio in. Browsers historically tended to have incomplete audio format support, forcing developers to include different formats for them to play on different browsers, but fortunately that's mostly no longer the case. We use the WebM format, which is an open format for both audio and video, and enjoys widespread support on most modern browsers. You can create WebM files from WAV or MP3 files. We created a command line-based pipeline for that in Project Flowerbed to automatically compress and process our audio, like we did for the models. As for playing the sounds, Modern browsers all implement the Web Audio API, which lets you play audio and gives you lots of fine-grained control over a sound's parameters, like the gain and the panning. However, it is fairly low level, so like with visuals, you can build them on top of an engine. There are a number of sound engines available, and some of the 3D engines like 3JS have their own sound components to work with the visual part. One of the most powerful features of web audio is that you can use it to create fairly immersive audio. By manipulating the Web Audio API directly, we were able to add filters, change gain, and apply various effects to our sounds. It also supports positional audio, which let us define both the listener and the sounds themselves in 3D space, which is very handy in VR. And finally, there are a few libraries that support ambisonic audio, which is a full sphere surround sound format. We didn't use ambisonic audio for Flowerbed, opting for stereo positional audio, but ambisonics can be very powerful in VR, especially for immersive videos. So now we've got visuals and we have audio, and it's time to put it all together. And now it's back to Scott, who will talk about the tooling that makes the development process a lot more pleasant.
My absolute favorite thing about building WebXR apps is the fantastic set of dev tools that make it really easy to understand what an app is doing and how it's performing. First of all, you can use Chrome DevTools remotely to learn all kinds of stuff about your app as it's running on your headset. By opening up Chrome's device inspector on your desktop machine, you can attach over ADB to a browser instance running on your Meta headset. After connecting, you can debug your running app, view your console output, see things like GL errors, and even track asset loading over the network. The DevTools also have awesome CPU and memory profilers that let us capture and analyze data from our app to understand our resource usage and performance, and find targets for optimization. You can see here how I recorded a few seconds of data from Project Flowerbed. And now I can click into a frame and drill down into the stack to see the runtime cost of different functions. Remote Chrome DevTools are a great way to understand what the app is doing on your headset. But if you don't have a headset handy, the WebXR Emulator plugin is a useful tool which lets you emulate a WebXR device on your desktop browser. Most of our developers use both the emulator as well as their headsets when working on Project Flowerbed. The emulator is great for quick iteration without needing to take a headset on and off, or just for situations where you don't have a headset ready. It's just another nice tool in the WebXR toolbox. Along with the awesome browser-side tooling, MetaQuest browser developers are also lucky enough to be able to use many of the great Oculus developer tools. For Project Flowerbed, we use the Oculus Developer Hub to continually monitor performance and resource usage, as well as to easily send ourselves URLs to view on headset. The Metrics HUD and OVR GPU profiler tools also work with immersive WebXR and are a great way to always have an eye on performance. If you want to learn more about these core Oculus performance monitoring tools, check out Jimmy Lee's Performance and Optimization on MetaQuest Platform talk, which is available on demand now. Finally, my absolute favorite developer tool is RenderDoc for Oculus. RenderDoc is fully functional with 3D web content and lets us capture, replay, and debug scenes on the GPU just like it does with native apps. The capture replays show us exactly what the GPU is doing, step by step, and lets us see exactly how our scene gets rendered. We can get hardware performance metrics from a replay to understand the GPU performance of our scene and find good candidates for GPU optimizations. RenderDoc also has viewers for all the data associated with every draw call it captures. It even lets us edit shaders within a replay and immediately see the results of those edits. I cannot recommend it highly enough, and I encourage everyone to incorporate it into their development workflow. Let's talk about performance a little bit more. Performance is critical for every VR app. The web shares the same performance constraints as native apps and has a few new ones. The same general performance tips for native apps apply to the web. Minimize your overdraw, avoid using expensive post-process effects, and use LODs and bitmaps where appropriate. Fortunately, most of the performance-focused Oculus platform features work in WebXR, including time warp, fixed foveated rendering, and phase sync. The web has a higher per-call cost for GL functions such as state changes and draw calls, so it's critical to use features like multi-view and instancing to minimize the number of GL commands you call each frame. All of the WebXR engines provide access to these features, but you need to make sure your content is using them. I feel strongly that one of the most valuable things anyone can add to their development process is to regularly use profiling tools to understand their application's behavior. Tools like RenderDoc make it easy to profile your application, understand your performance bottlenecks, and find optimization opportunities. By profiling your application on a regular basis, you won't just get better performance, you'll get a deeper understanding of what your app is doing and where to focus your effort. Good profiling tools are an amazing way to understand your application and provide a consistent path to significantly improve your performance and quality. Be sure to check out Dave Hill's WebXR development and optimization talk from last year's Connect to learn more about optimizing the performance of your WebXR app. I hope we've given everyone some solid direction on how to make amazing WebXR experiences. The thing I love most about building for the web is how easy it is to jump in and start creating fantastic things. And I hope everyone who's been watching today is excited to grab some of these tools and start building their own WebXR apps. Please go check out Project Flowerbed and keep an eye out over the next few months as we publish more learning materials and guides that will explore deeper into how we built it. Thanks for watching.
Hey everyone, you've reached the end of this track, but there is still so much more to come. You might actually have time to watch some of the other sessions that are finishing up, so just head back to the Reality Labs Facebook page or pop into one of the other locations within Meta Squared. Karen, were you able to catch anything?
Yeah, so I checked out the creator journey session because I actually already follow all of them on Instagram, and I've used their effects before. These effects, they're some of the most mind-blowing, innovative, creative stuff I've ever seen. And what really stood out to me was when they spoke to how they got started and how they started from really simple concepts and even felt insecure in the beginning. And then seeing how they evolved from that to become as impressive as they are today, I think that's just so encouraging for anyone who wants to get started in all of this.
It's so true. And I'm always awe-inspired by the creativity and the perseverance of this community. It makes the future even more exciting, which is yet another reason why everyone should stay tuned for our final bit of the day. Carmack Unscripted will be live broadcast at 2:30 p.m. Pacific from Meta Horizon Worlds. Now, to those already in the metaverse, head back to the outdoor screen in Meta Square. And while you wait, feel free to continue to explore, network, and chat with other attendees and discover more of Meta Square. Now, to those on desktop or mobile, grab a quick bite, grab a drink, get some coffee, get some tea, but make sure to stick around on the Reality Labs Facebook page as our time with Carmack will start shortly. You do not want to miss his unfiltered take on the future of technology, so we'll see you right back here very soon.